up, everybody? Dan here with Dan and Sarah Makers, and thank you for joining me for another episode of Tool Tuesday. Today's episode, we are going to be looking at wire strippers. Quick disclaimer, I am not a licensed electrician. I have not held an electrical license. I worked for an electrical contractor many years ago in a time and place where I was able to work under their contractor's license as an electrician. So, that is kind of a disclaimer. The things I show here are how I learned to do things, how I am familiar with them. Do not just take that and run and expect that to be okay in your jurisdiction. Every jurisdiction has an AHJ, or authority having jurisdiction. That is the electrical inspector. It could be your city, county, township, state, maybe even your country. And those people, those organizations have the final word in what does pass electrical inspection and what doesn't, and what meets code. Here in the United States, we have the NEC, National Electric Code. It gets written every so many years, or revised, I should say, every so many years. The NFPA, National Fire Protection Association, they have a lot of input. They co-write that electrical code with the NEC. That is because the Fire Protection Association is very concerned with electrical fires and electricity causing fires and structures. So they're very involved in writing the electric codes and updating them. So that being said, make sure you are using the correct electrical code that your AHJ is inspecting to. What might have worked 5 years ago may not work right now. They are constantly updating all sorts of things, and I've even watched inspectors discuss confusion about the newest issue to the NEC, how to interpret it. So an inspector looks at a kitchen island. That was one thing that they came out with how many square feet of island space requires how many receptacles. So what's a receptacle? Is a duplex receptacle two receptacles? Is a single receptacle where you just have one plug on a one gang box a receptacle? This inspector that works for the NEC and is involved in writing it wasn't sure exactly how to interpret it. So it's a little bit sketchy. Another thing, you may or may not be allowed to work and do electrical rough-in or repair work on your own house. Depending on where you live, you may be allowed to. Other places, you have to have a licensed electrician do the work for you. You may not be able to pull an electrical permit to do the work without an electrical contractor to do it. So some places I've heard, yeah, I paid an electrical contractor, they pulled the permit for me, I'm allowed legally to do the work myself, and then the electrical contractor comes in, inspects it, calls for the inspection, and walks the inspector through. So it varies depending on what area of the United States you're in. That may go for different parts of the country, different parts of the world, I don't know. But that's what I'm familiar with here in the United States. One of the most basic or simple type of wire strippers are these small little spring-loaded strippers. They have a small plier on the end, and then they have some stripping cutouts here. They'll also have a couple holes in the sides of the jaws, and those are for twisting the wire and putting a bend on it if you need it. This one is a channel lock. It has a little lock that keeps it closed. Not why it's called channel lock, that's just a brand. This is a smaller Ideal T-stripper wire is what it's called. This one goes up to 10 gauge wire, so the largest hole here. That's good for residential wiring because typically you won't find much larger than 10 gauge on typical residential houses, except for large loads like furnaces or air conditioners, things like that. But this will handle most of your other wiring. It's nice, it's small, it's compact, but kind of limited usage. This stripper here goes smaller. It goes from 16 gauge down to 26 gauge. And basically, the reason I got this particular one was when I was working on things like telephone wires and tech type AV stuff where you have really, really small conductors, doorbells, things like that. You want to be able to strip the wire without accidentally cutting it. The next style of wire stripper, which I like a little bit more, if you see, one is a Klein, one is Milwaukee. They are almost identical. Same capacity, same bending holes. These now have two side holes on the jaws, and those are designed for cutting screws. They have the 632 and 832 screw sizes. Those are really common for cover plates and mounting receptacles and things like that. So if you ever run into a situation where a screw's too long, you can cut the screw. Very little difference, as I said. I mean, they almost look the same, jaw style. The only difference would be the Milwaukee has a way to tighten up or loosen up the hinge screw. This is just a solid rivet. And then the lock jaws are just slightly different. So other than that, they're almost identical. Very, very, very similar. They have warnings on them because this is, as you see, both of them have a kind of a fat handle on it with an inner liner that's a different color. That can be misunderstood as an electrically insulated tool because a lot of times they'll have the comfort abrasion layer and then the actual insulation layer. So say this yellow was the insulation to protect you from a shock. If this outer cover was damaged in such a way that you could see the brighter inner color, then you would know that it's time to not use that insulated tool anymore. But these are just for comfort, just for ergonomics, kind of give you a nice fat handle. That is not insulated. Both have warnings on them telling you they are not insulated. This set of channel locks here, this is kind of a really nice one and done electrical stripper and crimper. It is not quite as nice. It doesn't have a spring to open it up and close it, but it's got our stripping different wire gauges that we can strip up to 10 gauge. It's got a little pair of jaws up at the nose. It's got a lot more screw holes for cutting screws, many more sizes, and you get up to 1032, which is a little bit larger than the 832, so you're starting to get into like a hangers for heavier light fixtures and things like that. So that's nice. They had those many 6 different screw sizes instead of just 2. It's got a loop for bending wire. And then down here on the back side of the jaw, it's got a lot of areas for crimping connectors. So if you have those little blade connectors or prong connectors, hoops, things like that, you can crimp those on down here. Klein came out with a couple of these specialty electrical strippers. These are very, very specific to a residential rough-in electrician. If you notice, it has a very unique jaw. It's cut out with a lot of different grooves and things like that. But this is designed, this plier here is specifically for 12 and 14 gauge wire and Romex wire. So up at the nose, it's got the little plier. It's got a 14-2 Romex stripper. It's got a 12-2 Romex stripper. It's got 14 and 12 gauge strippers. And then it's got kind of an aggressive cutter back here that keeps the wire from sliding out when you're trying to cut. It also has our 632 and 832 screw cutter and bending holes. It's got a lock, it's spring loaded. And then this one is similar to this pair of pliers, but this one is specifically for 12 gauge wire. So like 12-2 Romex. So if you notice, it's got a bent jaw, 90 degrees, and it's got the stripper for Romex sheeted or sheathed cable up here on the nose. That means I can reach into a receptacle box, grab it like that, and pull the outer insulation or cut it easily up inside the box. Can't do that with this as easily or at all, so that's where this one's nice. It's, again, got the really kind of aggressive cutter that grabs the wire and holds it and keeps it from sliding out. And this one has a 12 gauge solid wire stripper, and it also has a stranded 18 gauge wire. This is more of an electronics kind of wire stripper. Basically, when you pinch it, it's got 2 jaws that have blades that pinch the wire on either side, and then it's got a second jaw that closes slightly after and grabs the wire. And so when you do this, it actually cuts and pulls the insulation off the end of the wire. This is a pair of Knipex needle nose pliers, basically, but they're for electrical work. They have a little bit of a jaw here that's grippy, and then they have 3 holes here for actually stripping wire. And again, it's a 10, 14, and 12 gauge, so you've got your standard wire sizes for residential wiring, and then you've got a little bit of a crimp back here in case you want to crimp something. These 3 strippers here are, again, Romex specific. It's designed to cut the outer sheath off of Romex wire. This is probably the most basic. It's just a piece of stamped sheet metal, and it's got a little tab bent in for the actual cutter that's in the center. Basically, you open this up, you slide it over the insulated Romex wire, you squeeze it together with your thumb there, applying pressure, and you pull it off the wire, and that will hopefully cut the outer jacket on the Romex wire. So this isn't that good of a tool. I don't like it that much. I don't use it that much. I used it way back when better stuff came, until better stuff came out, and I purchased it, but it's just kind of a little chintzy wire stripper. The strip awl is kind of my go-to for Romex most of the time. It's spring-loaded. It's got a depth adjustment here, a little dial, and there's a small razor blade that sticks out. What's nice about this is I can stick my Romex wire in there, squeeze it, and then just pull it, and it will reliably cut right in the center of the Romex sheath where the ground wire is. So I'm not worried about cutting my insulated conductors or anything like that. So this is my go-to personally. It's got a small pocket knife on the end here. Well, I guess it's not a pocket knife, but a folding knife. And when you reach up inside a box, you can squeeze it, cut it, strip your outer sheathing insulation back and around, and then reach up in there and cut it off with the little knife. This is similar to the previous one. It's got a razor blade or a knife blade sitting right here and another one on the other side. This side is for 10 gauge insulated Romex style wire, and then this side here is a little bit smaller. This trough is a little bit smaller, and it's designed for 12 and 14 gauge Romex. This one I don't like so much because if you're holding the end of the wire, you can only strip it so far, and then when you're trying to push down, the wire's just bending out of the way. Or you put your thumb on top of it and you get to the end of the wire and your thumb dives down on that razor blade and you might cut yourself. So it's okay in some situations, not that great. I'm not a big fan of it, but it is another style of wire stripper. And of course, all the bells and whistles aside as specialty tools, we can just use a utility knife, either a straight blade, extendable, or just a standard utility knife. You can use these to cut the Romex wire, the outer insulation, if you're careful, or you can actually cut the insulation on the individual conductors. Again, if you're careful. They're not the best, but they do work. Is it important to use the correct size stripper for the correct size wire? I would say yes. So, this is a 12 gauge wire. I strip it with a 12 gauge stripper, and then I can bend it. This is soft drawn copper wire, which means that it is a little bit brittle. If I go down to, say, 14 gauge, and I crimp it, and I pull that insulation off, when I go to bend it, it probably won't happen, but we'll see if it does. If I bend it multiple times, there's a good chance, of course it won't happen on camera, but there's a good chance that that little score in the wire can actually cause the wire to break. I don't know how many times I've seen receptacles where you open up the junction box and, you know, the receptacle doesn't work. I smelled something burn, I heard a buzz, I heard something, you know, and you pull the receptacle out and it's got the little loop of wire stuck to the side of the receptacle, and the insulated wire is broken right at the edge of the insulation. So let's see, maybe I can do that. We'll drop it down to a smaller size here. Doesn't happen all the time, but there. I went down one size and it's very, very easy to break the wire because it's been scored right there. We'll try the 14 again. So 14, it's not quite as bad, but a couple bends and it does snap off. So you're scoring the wire, you're creating a weak spot. That's where you're going to have receptacles and switches that don't work, light fixtures don't work, and you run the risk of arcing, tripping breakers, GFCIs, things like that. If you're dealing with conduit, you'll most likely be utilizing individual conductors, stranded conductors, and this is where, or when the actual wire itself is a stranded conductor, where it's a lot of little filaments. There are different sizes of these stranded conductors, but this is pretty typical for a 12 gauge wire or 10 gauge wire. Again, like I said with the Romex, if you use the wrong size stripper and you cut it, yeah, you strip the insulation off the outside, but if we look at what's left, I've cut a lot of the actual conductors out. Sometimes it'll only be a few, sometimes it'll be quite a bit. But you don't want to use an undersized stripper and cut a bunch of the conductors. This is another stranded wire. This one's actually welding cable. If you look at this, it's got a lot of very, very fine copper wires in there. Something like this, they don't really make a good stripper. So my recommendation would be to score the outer insulation lengthwise to the length you need, peel it back, and then very carefully start cutting around the circumference of the insulation with a utility knife or a razor knife of some sort. Again, these are very, very fine conductors, so you don't want to just use some big stripper and run it around the perimeter that's not designed for this particular size wire and cut a bunch of these conductors. One of the first things I want to mention when you're dealing with Romex wiring is code states that this wire needs to come 6 inches beyond the face of the box. That is the face of the box, not the back. So if you're going to measure, it isn't back here, you know, it isn't 6 inches there. It's actually from the face of the box out 6 inches. So this is about 6 3/4 inches. That would meet code. A lot of people, because Romex is very expensive right now, they're going to want to minimize that. So don't do that, because there are very few inspectors that will say, yeah, it's fine, put a wire nut on here and extend those wires out. Some may not. So don't risk it. Make sure those wires come out far enough. Now, a good rule that I was told is if you take the back of your hand, put it against the face of the box, and then stick your thumb out, that's pretty close to 6 inches almost always. Currently, this much wire, I'm not kidding, is 30 cents worth of wire. A foot at a good price is about 61 cents a foot currently. The most standard way of stripping this wire, you want to run it into the box. Typically it'll be insulated. These will get rolled up and pushed back in the box for when the drywallers come through, because they'll take their roto zips, they'll dive into the center of the box, they'll go to the edge, they'll jump the edge of the box, and then they'll trace around the box to cut their drywall and slap it up. We don't want our conductor getting damaged on the insulation or even cut through. A roto zip will cut through the copper wire, and you'll have one conductor cut back here and the other two are out and it's covered with drywall. So not a good thing. So tuck them back tight, and then once the drywall's done, then pull it out and get it ready to go. So like I said, my go-to for this step here is a strip awl. It's got the little razor blade. I'm going to stick it up inside the box. I'm just going to squeeze it, and then I'm going to pull it straight out, and it cuts that sheathing, the outer sheathing, and it gets it back in there, and I can peel it back up out of the way inside the box. And it's got this little knife here. I don't always use the knife. Sometimes I'll just use my utility knife. But I can cut that insulation off, reach up inside the box, and then I just pull the paper off. This Romex has been sitting outside, so the paper's wet. Not good, but that's why that's wet. So now I've got my 3 conductors. I've got my neutral or white wire. I've got my ground, which is my bare copper, and I've got my black conductor. I would then move on to some sort of wire stripper. And to me, I already know which one of these grooves I need to use. It's a 12 gauge wire, so it's the second from the end. And I also know approximately, just by feel, how far down to strip the wire. Usually 3/8, ½ inch. A lot of receptacles and switches will have a strip gauge on the side of it, so you can figure out how much wire insulation to pull off. So if I am going to a wire nut or a backstab style receptacle, or a receptacle with a side clamp plate, I would use just a straight piece of wire. I wouldn't, focusing on the wrong thing, I wouldn't do anything beyond this. If I was going to a more inexpensive receptacle where I would need to wrap this around a screw terminal, I would then take one of these holes here in the side of my plier, stick the wire through just enough so it comes out the other side, and I would twist it and put a 180-degree bend on it like that. One thing I see quite often in renovation work and remodels is that a new box gets installed. The wire, the Romex in the wall isn't quite long enough, and the outer insulation on the Romex cable is cut up here and it doesn't go inside the box. You never want to see that. You always want to make sure that that outer insulation is all the way inside your box. You can't have it cut out here. If it is like that, you're not going to pass. The inspector will say, nope, it needs to be inside the box. So don't do that. That's one thing also where somebody that may be wanting to cut wire to length and they think they've got a good measurement and they cut it and they strip it because it's easier to do it when it's not sticking in the box or it's not inside the box. They pre-do it and then they try and stick it in and they find out that they've got 2 inches too little wire and it doesn't stick out the 6 inches. It's cut back up here, so don't do that. And finally, for stripping that insulation off, if I don't have the fancy bells and whistles, the simple stripper, the Klein bent nose 12-tooth pliers, I'm just going to use a utility knife. This is where you have to be a little tricky. You just use just the tip of the blade and you just score and try your best to follow the center of your Romex insulation. Not bad. I'm left-handed. I did that right-handed. You just want to score there. That way if the knife tip does score the conductor, you're just scoring the ground wire and not the actual insulated conductors. So I just peel off the sides and then cut my outer jacket off. Thank you for joining us for another episode of Tool Tuesday here on Dan and Sarah Makers. We really appreciate your views. If you like this video, if you want to support us, like, comment, share, subscribe, thumbs up, all that good stuff. You can follow us at Dan and Sarah Makers on Instagram. Those all help us out a lot. I have an Amazon affiliate link, so down below, if you look below, I will try and link as many of these tools as I can down below. You can follow that link and purchase the tools for yourself. Get it delivered right to your house. You don't have to run out and see if the store has it or not and deal with people. It does help us out a little bit, so that definitely helps our channel out. So we really appreciate it if you make those purchases, and it doesn't add anything to your price that you pay for that tool. So until next time, we hope you have a good one, and we'll see you next time. Bye.